Questions 11 through 20 of the 2000 Grade 10 Cayley Math Contest. A store had a sale on t-shirts. For every 2 t-shirts purchased at regular price, a third t-shirt was bought for $1. 12 t-shirts were bought for $120. What was the regular price for one t-shirt? So the scenario here is you buy a t-shirt at regular price, another one at regular price, and then the third one you get for $1. Like that. So regular, then $1. And you are buying 12. So instead of one time, you're doing this 4 times. RR1, RR1, and finally RR1, right? Because there's 12 t-shirts that have to be accounted for. And they're saying this total is $120 right there. So you just add this all up and solve for R. Right, that. So this looks like 120 is equal to, I believe, 8R plus 4. And therefore this is 116 is 8R. And R will be 116 over 8, which is 14.5. So the regular price for one t-shirt is $14.50. So the answer is D. Natural numbers are equally spaced around a circle in order from 1 to n. If the number 5 is directly opposite 14, then n is. All right, let's draw ourselves a circle. And they are telling me that the number 5 is directly opposite 14. So it's sort of like a clock, but not exactly, because clocks wouldn't have that kind of a scenario. But you can kind of think of it like that. Now let's concentrate on this part first, because we know what digits we have. We've got all the natural numbers, whole numbers, integers, whatever term you want to use, from 5 to 14, equally spaced. That's the key there. So let's see if I can do this the best that I can. We're going to have, let's see, 6, 7, 8, 9, 10, 11, 12, 13. All right, so that's pretty equally spaced. How about this side here? Looks like there's going to be the same kind of thing where I have 4. So 1, 2, 3, 4, like that. And therefore you have to fill in our final part right there. So it'll be 15, 16, 17, and 18. And that is a pretty decent illustration that matches the requirements in the question stem. So what are they asking? Then n. What is the final number, 1 to n? So n in this case is 18. So the answer for number 12 is D. The average of 19 consecutive integers is 99. The largest of these integers is 19 consecutive integers. So n plus 1 plus n plus 2 plus n plus 3 all the way to n plus 18. That's the 19th consecutive integer. And they're talking about averages, so you're going to divide by the total, and they've told you that is 99. So now we can just solve. How many n's do we have? Well, there's 19 of them. So we got 19n. And then you have 1 plus 2 plus 3 all the way until 18. And then cross multiply 19 times 99, which is 1881, like that. And then these numbers, there's a special formula. Anytime you're adding numbers that are consecutive up until a certain number, and that number is n, the sum is n times n plus 1 over 2. It just saves a little bit of time. So in this case, don't get confused. 18 is n. So we got 18 times 19 over 2 is 1881. So this looks like 19n plus 171 is 1881, and therefore we have 19n is equal to 1710, and 19n being 1710, that means n is equal to 1710 divided by 19, and therefore n is equal to 90. Now they didn't want n, they wanted the largest of these integers, and the largest of these integers is n plus 18. So n plus 18 is equal to 90 plus 18, which is 108. So the answer to number 13 is B. A positive integer is to be placed in each box. The product of any 4 adjacent integers is always 120. What is the value of x? All right, let's start with this, move in this direction. So I'm going to label them A, B, C, D, E, F, and then by the time I get to F, hopefully we'll have figured out x. So I'll first concentrate on these 4. 2 times C times D times 4 is equal to 120, right? Because they're 4 adjacent integers. So that means that C times D is equal to 120 over 8. So C times D is equal to 15. So if there are any integers that when you multiply them together give you 15, well, 3 and 5, that would work like that. So that means C can be 3 and D can be 5. All right? So now let's keep moving forward here. We've got 3, 5, and 4. So let's concentrate on those 4 now. 3 times 5 times 4 times E is equal to 120. And if you solve, you'll get E is equal to 120 over 3 times 5 times 4. And therefore E is equal to 2. Okay? So now we can put 2 in here. And moving forward, now I'm going to look at these 4 right here. Those 4. So we have 5 times 4 times 2 times F is equal to 120. And therefore F, if you solve, it will be equal to 3. So now I've got 3, and then now finally, I can finally figure out x by concentrating on these 4. So 4 times 2 times 3. Actually, you know what? Let's not use the x's. That makes it confusing. Let's use brackets. 4 times 2 times 3 times x is equal to 120. And therefore, if you solve for this, you'll get x is equal to 5. So the answer to number 14 is E. Eight squares with the same center have parallel sides and are 1 unit apart. The 2 largest squares are shown. If the largest square has a perimeter of 96, what is the perimeter of the smallest square? So there's 8 squares and each is inside the other. So we've got small square, that's the first one, second one, third one, 8 squares, right? So 1, 2, 3, 4, 5, 6, and 7, and we got one more, 8. All right. So first, they're not perfect, but you get the idea. All right, so first of all, let's count. 1, 2, 3, 4, 5, 6, 7, 8. All right, so I fulfilled that criteria. The largest square has a perimeter of 96. Okay, so the whole perimeter is 96 for the largest square. Perimeter of a square essentially is 4 times the side. So if the side is x, the perimeter would be 4 times that. So 4x is 96, and therefore x is equal to 24. So this large square will have a side of 24. And then if you see right here, they've put these little ones in there to show you that that is the distance from one square to the next. And the question stem also tells you the same thing. So that means that from here to here is 1. From there to there. And therefore, on the top, from there to there is also 1. Correct? So this is 1, and that small distance is 1. So therefore, the next square, its side, is going to be 24 minus 2. So, which is 22. And very similarly, you can do the exact same thing for the next square side, 20. And then the next square, 18. And you get the point. The next one looks like it's here, so that would be 16. And the next one over is this one. That is 14. And then the next one over is here. That's 12. And finally, ran out of space, but I can squeeze it in there. That one, the very smallest one, is 10. So you're just subtracting by 2 every time. So the very small circle has a side of 10, and therefore the perimeter of the smallest square will be 4 times 10, which is of course 40. So the answer to number 15 is A. In the diagram, ABCD is a rectangle with AD equal 13, D equals 5, and EA is equal to 12. So let's draw this a little bit bigger. So they've given us a little bit of information, and let's fill that in. AD is 13, DE is 5, and EA is 12. Well, immediately you probably notice that this is going to be a right triangle because 12 squared plus 5 squared is equal to 13 squared. So therefore this is a right triangle like that. And then there's several ways of doing this question, and there's a long way which introduces variables, x, y, like that. And then this would be 13 minus x. And then you use these two triangles and figure out a relationship, and then you equate them to each other. And it completely works, but it's kind of time consuming. One quick thing I noticed is that if you drop a perpendicular all the way from E to the other side, something really cool happens. It splits the diagram into 2, and each of those sections has a diagonal. And what that basically means is that this area right here is the exact same as this area. And therefore on the other side, the same story. This area is the exact same as this area. So if we can figure out the area of this triangle in here, all we have to do is just double it and we get the area of the rectangle. And can we figure out the area of triangle ADE? Of course we can. Triangle ADE is 1/2 base times height. The base, we can call this the base, which is 5. The height, we can refer to that as the height, which is 12. And therefore, this looks like 30. So therefore, the entire rectangle is double that, because like I had previously mentioned, this part is the same as that part, and this part is the same as that part in terms of area. So the area of the rectangle is just 2 times this 30 that we figured out, which is 60. So number 16, the answer is B. In the regular hexagon ABCDEF, 2 of the diagonals FC and BD intersect at G. The ratio of the area of the quadrilateral FEDG to triangle BCG is. So they want you to find the ratio of this quadrilateral to this triangle. So I'll write it over here. Find FEDG over BCG, like that. All right, I am going to draw this a little bit bigger. Okay, I think that should be sufficient. Now I'm going to just start labeling things. So it's a regular hexagon, so that means all the sides are the same. So this is X, 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 like that. And now I want to illustrate some angles. Well, this one's easy. This is just 90 degrees. And remember, in a hexagon, the sum of the angles, the sum of all the interior angles, is equal to 720. So we're talking about this angle plus this angle, that one, that one, that one, and that one. Okay? All those angles, if you add them all up, it's 720. So each angle is 720 over the number of angles. So it was 1, 2, 3, 4, 5, 6. And this equals 120. So what that means is that this angle is 120. And similarly, that angle is 120. So we already labeled this to be a 90-degree angle. So that means this angle in here has to be 30 degrees. Like that. This is a right angle, so this angle has to be 60 degrees. Okay? So that is a 60, 30, 90 triangle. Very important. So what I'm going to do, instead of messing up the diagram, I'll draw a triangle over here, like that, to represent this little guy over here, to represent this triangle, because it's kind of small, I don't want to mess it up. So 30 degrees there, 90 and 60. And this has already come up so many times just in the last few videos, this 30, 60, 90 triangle. It comes up a lot and very helpful. And what I'm referring to is the ratio of the sides. The side opposite 30 is 1, the hypotenuse is 2, and the side opposite 60 is root 3. This is the ratio of the sides, not necessarily the length of the sides. So if we have even 1, we can figure out the other 2 from this ratio. Well, we do. We have 1. Well, I labeled it X. So that's X. If that is X, then that means this side is X over 2, and this side is root 3 X over 2. All right? If you practice this a few times, you'll be able to do it in your head very quickly. So the good news is, because I have all the sides, I can figure out this area right there. So area BCG, like that, triangle, is 1/2 base times height. The base is from here to here, which is right there, X over 2. And the height of BCG is right here, which is root 3x over 2. So this looks like it simplifies to root 3x squared over 8. All right, so I've got 50% of what I have to find. Okay, moving right along. Now we turn our attention to this big guy right here. We have to figure this out. Well, the first thing I want to do is drop a perpendicular from E to this side, like that. And when you do drop that perpendicular, I hope you'll see that we have something very similar to what we just previously did. We have another 30, 60, 90 triangle. This is 90. Remember, this whole thing was 120, so therefore this angle in here is 30. Can barely squeeze it in. And therefore this angle will be 60. All right? So I will, again, just the way I did, I will draw that triangle over here. So I've just replicated it instead of trying to make the diagram all messy. So I replicated essentially this triangle F, the one that's bounded by FE. So this was F, this is E. So this is 60 degrees, this is 30 degrees, and this was 90, right? And we know that this is X. Very similar to what I did over here. We've got a ratio of 1, 2, and root 3, like that. Okay, so this is X, so therefore this is going to be X over 2, and this is going to be root 3, X over 2, like that. So now, if I have to figure out the area of this triangle, it would be 1/2 base times height. This is the base, X over 2, and this is the height, root 3, X over 2. But I also have to add this square, or rectangle, whatever shape it is. It's probably a rectangle. And that's, of course, pretty straightforward. That would be X, that part there, times that side, which is over here. It's root 3, X over 2. And what did I just figure out here? Well, I figured out our quadrilateral, FEDG, like this. Okay? So I hope that made sense. Now we just have to figure out the ratio. We've done both of them. So FEDG over BGC. FEDG over BG or BCG. Same thing. All right, the top is going to be, we've got it right here, root 3x squared over 8 plus root 3x squared over 2. Okay, and then BCG is right here, this guy, root 3x squared over 8. Okay, the good news is that the x squareds all cancel out, these guys. The root 3's all cancel out, those guys. And that leaves us with just 1/8 plus 1/2 over 1/8. So let's do this now. We got 1/8 plus 4 over 8 all over 1/8. And this looks like 5 over 8, invert and multiply, 8 over 1, and this just becomes 5, or 5 over 1. So 5 over 1 is the ratio of the area of the quadrilateral FEDG to triangle BCG. So which one of those? 17 is E. If A, B, and C are distinct positive integers such that ABC is 16, then the largest possible value of A to the B minus B to the C plus C to the A is. Okay, so ABC is equal to 16. If we factor 16, we get 2 times 2 times 2 times 2 times 1. Prime factorization. And we want ABC, we want it in this form, 3 integers. So how do I get 3 different integers? Right now I have a lot of 2's, but I have to make sure that A, B, and C are distinct. They're different. The only way I believe you can do that is by grouping these guys together to make that an 8, and then having a 2, and then having a 1, like that. That's the only way you can get 16 factored into 3 numbers that are all different. All right, so we got that part. Now let's figure out this expression, a to the power of b minus b to the power of c plus c to the power of a. And we want to make it largest as possible. All right, so just let's trial and error here. The first thing I notice is because we want it the largest, we want this to be large as possible. So I'm going to make a the 8. And let's just do 2 and 1, and then we can kind of go from there. All right, so if a is 8 and b is 2, this is what I'm going to get. 2 to the power of 1 plus 1 to the power of 8. All right, let's figure this out. So we have 64 minus 2 plus 1, and this equals 63. Okay, which is one of the answer choices, but let's keep going here. Perhaps we can get a bigger number. Now I will choose A, B, C. I'm still going to use 8 because I have to keep that as large as possible, but I'll just flip the B and C like that. So now my expression becomes 8 to the power of 1 minus 1 to the power of 2 plus 2 to the power of 8. All right, so this is 8 minus 1 plus 2 to the power of 8 is 256. So this becomes 264 minus 1, so 263. So that's pretty big. And I think that's the largest one that they give us. So yeah, there's no answer choice larger than that, so that's got to be the answer. So 18 is D. A metal rod with ends A and B is welded at its middle, C, to a cylindrical drum of diameter 12. The rod touches the ground at A, making an angle of 30 degrees. The drum starts to roll along AD in the direction of D. How far along AD must the drum roll for B to touch the ground? All right, interesting question. So, do we need to draw this a bit bigger? Sure, what the heck. So this is the initial scenario of this diagram, and what's happening is that this cylindrical drum right here is going to start rolling. So this drum is going to start rolling in that direction. And eventually, as it rolls, this rod starts to move. So for example, right now it's in the position that you see, but as it moves, for example, when the cylindrical drum is here, the rod will be like this. Do you see what's happening there? And then eventually, when the cylindrical drum is at a certain point, the rod will be in this position. And therefore B, which is I guess one end of the rod, will be touching the ground like that. And they want you to figure out, how far did you move? So you were initially there, and now you're here. How far did you move? All right, so you got to understand that before I move forward. So if you don't, rewind back, listen to it again. Or you can just draw it out yourself and kind of figure it out for yourself. That's always very helpful. So let's draw this out a little bit more cleaner. So I have drawn it out a little bit cleaner, and I wanted to illustrate what is happening here. So this circle right here started to move in that direction, and eventually it came to here. And when it did, you'll notice that C is now right here, and B is now here. This rod that was originally in this position has now followed the drum and is now in this position. And just like the question says, B is now touching the ground. And this circle was initially sitting on the ground at this position. Now it's sitting on the ground at this position. So they want you to figure out the distance that it has traveled. So that distance is what they want you to figure out. Okay? And how are we going to do this? Well, we do this with angles. Angles is the key to this question. So here we go. I'm going to draw in a few very helpful lines. So the first line I'm going to draw is a perpendicular that goes through B all the way to the bottom like that. Then I'm going to draw a line that's parallel like that. And I think that should be it, but I'll draw one more just in case. I'll draw it over here so I don't mess up the diagram. And one across like that. I think all of these lines should be sufficient. Alright, so now let's start labeling the angles. This is 30, which they've already given you, and this is a right angle. So therefore, this angle in here is 60 degrees right there. And therefore, since this was a right angle, this has got to be 30 degrees. Okay? So far I hope that makes sense. Now similarly, on the other side, I hope you see that this side over here is essentially just a reflection of that side over there. It's the same kind of thing. So if this is 30, then this is 30. It's the same rod. It's just now on the other side. And therefore this angle in here is 90. And therefore this one is also 60. Okay? So I hope that makes sense. And then this angle in here, if I can squeeze it in, is 30 degrees. Alright. Now where do we go from here? One final line that I saved for last because I wanted you to understand the diagram is I'm going to extend this line right here. I'm just extending it like that. And the reason I'm extending it is so that you can see one final angle that's going to be very helpful for us, and that's this angle right here in there. That angle is the same as this angle, and which is 30 degrees. All right? Because this line is parallel to that line, and this is just the straight line across. So just from the rules of angles, we learned that this rod that was originally in this position right here has moved essentially from here to here into that position like that. And therefore that rod moved 60 degrees. And that's the key to the question. It moved 60 degrees, so therefore this cylindrical drum rolled 60 degrees. All right? So that is the essential crux of the question. 60 degrees. So if you moved 60 degrees as a circle, you moved 60 degrees on your circumference. Now the full turn, one full turn, is 360 degrees, correct? But we have only moved 60 degrees, which is 1/6. So this cylindrical drums, although it doesn't seem that way, because I had to make this diagram very big to illustrate all the angles, this cylindrical drum has only moved 1/6 of its circumference. Okay? So, how do we figure out what is 1/6 of the circumference? We figure out the circumference, which is pi times diameter. So the diameter of this we've been given is 12. So the circumference of the circle is 12 pi. We've traveled 1/6 of it. So 12 pi over 6 is 2 pi. That's how much we've traveled. From here to here is 2 pi. Now I know it doesn't seem that way, but don't worry about the diagram being drawn to scale. I had to draw it big. It's the only way I could fit in all the angles. But the correct answer is indeed 2 pi. So number 19, the answer is B. 20 pairs of integers are formed using each of the integers 1, 2, 3 up to 40 once. The positive difference between the integers in each pair is 1 or 3. For example, 5 can be paired with 2, 4, 6, or 8. If the resulting differences are added together, the greatest possible sum is. So first, let's understand this question. We have been given a set of integers. 1, 2, 3, 4, 5, all the way up to 40. 37, 38, 39, 40. And from these integers, we have to create pairs. So we have to create pairs like this. And we have to create pairs such that the difference between the two integers is either 1 or 3. So, for example, if I chose 40, I can choose 39 to complete the pair. Why? Because the difference between 40 and 39, if you subtract them, is 1. And that matches a criteria. If I chose, say, 38, I can put a 35 because the difference, 38 minus 35, is 3, and that is also part of the criteria. So you're going to choose a whole bunch of pairs. Well, there's going to be 20 pairs, right? Because there's 40 numbers, so 20 pairs. I'll just put that in here, 20 pairs. And what they want you to figure out first is for each pair, what is the difference? So for example, in this one, the difference was 1. Here the difference is 3, and so on. And then you're going to take all those differences and add them up. All the resulting differences are added together. And they want you to find the greatest possible sum. All right, so that's the essential explanation to the question. So how do I do this? They want the greatest possible sum, right? If they want the greatest possible sum, each individual difference should be greatest. So I'm going to forget about the ones. I'm not even going to do any ones. I'm going to make all of my pairs have a difference of 3. If I do that, I can add them all together and get the greatest possible sum. So here we go. We got 40, and I'm going to choose 37. That way the difference is 3. I got 39, I'm going to choose 36. That way the difference is 3. 38, I will choose 35, making the difference equal to 3. So I hope you understand what I'm doing here. I'm adding, all of these together. Next one over, 34, 31, and so on. Okay, I'm not going to draw them all out. You can if you want, if it helps you understand the question better. But I can. Maybe you know what? I will. It'll help you understand the question a little bit better. So 33 and 30, the difference is 3, and so on. So I've written them all out for you, and you can see for each pair the difference is 3. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we've got 19 pairs. Each has a difference of 3. So the sum is 19 times 3, which is equal to 57. All right. But if 57 is not one of the answer choices. Why? Because I've only chosen 19 pairs. There's one pair left that I didn't write purposely because I wanted you to understand that so far everything's fine. I've done the maximum I possibly can. The one last pair that's remaining, the two numbers that are remaining, are 3 and 2. So our very last pair is 3 and 2. Its difference is not 3, it's 1. So I've got to add 1 to this, and therefore the total is 58. So number 20, the answer is D.